So I'm presenting a research update on the Atikokan Transect. So our collaborator from industry is Nico Eagle, and in terms of academics, and I apologize, I should have included as well University of Toronto for the geocon data. So I will be reporting on the preliminary result of two MSc projects. One by Mohamed Farhat on the stratigraphy and structural geology of the steep rock greenstone belt. And the second project is by Gabrielle on the geology of the Hammond Reef deposits. So the Transect area is within the Marmion terrain, and we can see it from in this slide. So this shows the path, if you wish, of the Transect. It goes from turbidite of the Quatico subprovince across the Quatico fault into the steep rock greenstone belt, the Marmion complex, which is Mesoarchean, Finlayson belt, and then ends up into a younger Pluton at 2680. This shows the ages. The Marmion age is dated at, it's Mesoarchean, dated at 3 billion years. Then we have the diversion stock along the margin of the Marmion age, which is dated at 2780. And then greenstone belt. The greenstone belts are Mesoarchean in age, the Lumby Lake greenstone belt, the Finlayson greenstone belt, and the steep rock greenstone belt, which will be one of the focus of this talk, which is also Mesoarchean, but is thought as well to have Neoarchean volcanic rocks. This is a simple stratigraphy for the area. We start with felsic magmatism, both rhyolites, but also the tonalites of the Marmion complex at 3 billion years. Then we have mafic rocks at 2.9 to 2.96, and a nonconformity, which is younger than 2.78 billion years, or the age of detrital zircon within the Wajika formation, which is a conglomerate, which is unconformably overlying the older Mesoarchean crust. And this is part of what is called the steep rock group, or the steep rock sequence, which is a platformal sequence overlying the older cratons. Then the Wajita is overlain by Mosher Formation, which is an Archean limestone with stromatolite, quite famous. The Joliffe Formation, which is an iron formation, and that was what was mined historically in Atikokan. Then the Dismal Ash Rock Formation, also containing detrital zircon at 2780. It's an ultramafic lapilli tuff. And then the Whitby Formation, which is dated more recently at 2730 million years to 2735 million years. But notice those are intrusions that are interpreted as being volcanic. Okay, so we'll focus now on the MSc project of Mohamed, and Mohamed focuses on the stratigraphy and structural geology, basically of the Whitby Formation. And he's testing two interpretations. One interpretation is that we have a conformable sequence, that the Whitby Formation and the Dismal Ash Rock are autochthonous or deposited within the platformal rift sequence represented by the steep rock group. The second interpretation is that it's the trusted sequence, the Whitby allochthon, or the Whitby Formation or assemblage is being trusted above the platformal sequence. So his thesis is to test those two interpretations by working mainly on the stratigraphy, but also the structural geology of the Whitby Formation. We can summarize quite easily the structural geology with this diagram and those two photographs. There's a nice strain zone shown in red, which is in between the pyroclastic ultramafic rock and the Whitby Formation. So to the north is the ultramafic rock, Wedge Formation to the south. And it's either the thrust faults, according to the model of Koski, or it would be simply a highly strained depositional contact according to the interpretation of Tomlinson. We can see here this is taken within this ice rain zone. We have the strong foliation, which is folded with the formation of an axial plane cleavage. This axial plane cleavage is axial planar to those regional northeast trending folds, which are cut along their limbs by ice rain zones. And the folds and those ice rain zones, and we'll see the Marmion shear zone is one of those ice rain zones, are then getting rotated or dragged in clockwise fashion into the Poetico fault, which is known as being a dextral fault, has been demonstrated by Gaetan. So this is a picture of the Poetico fault with the shallowly plunging stretching lineation. Okay, so Mohammed did work on 3 sections that represent the complete section of the Wedge Bay assemblage. So this would be the base of the section where the Wedge Bay Formation is in contact with the ultramafic rock. That's the middle section, that's the top section. So the Strat section, Tuft Lake section, and Burn section. So this is quite representative of what we're seeing in the lower part of the Wedge Bay Formation. We have massive flows, pillowed flows, and as well at the contact between the two, just overlying the massive flows, we have those spectacular breccia with those amoeboidal fragments, but also you can see some volcanic dikes with new fragments budding up from those volcanic dikes. If we move up the pillowed flows, we have very nice top indicators with the rounded top of the pillows and the tails of those pillows. So we've looked at the lower part of the section, and within that section we also have some felsic lapilli-tuff, and we dated, actually when I say we, Mike Hamilton and University of Toronto dated this unit, and it yielded ages of 2890 million years, which is Mesoarchean ages, which was surprising because this sequence is thought to be Neoarchean. Note though that those zircons are quite altered, and this is why there is a question mark beside this age. Now we'll be looking at the top part of the Wedge Bay Formation, where it's in contact with the Mosher limestone. Remember, the Mosher limestone is part of that platformal sequence of the steep rock group. So we'll move to this section, to the Burn section, and then we'll come back to the Tuft Lake section. So this is a detailed map, and what it shows is the volcanic rocks of the Wedge Bay Formation. And so it shows here as a mafic lapilli-tuff. You move closer to the contact with the Wedge Bay Formation, with the dismal ash rust ultramafics, which are seen here. And what you're seeing is a volcanic sandstone that is forming because of the erosion of the mafic volcanic rocks. Now, coming back, this section here, we can see massive flows. And when we look at the textures within those massive flows, we have a massive base, a amygdular center, and a flow-top breccia. We have this repeating itself 3 or 4 times, indicating a yawing direction towards the southwest, which is the same as the straw hat section, and which is dating towards the ultramafic rock. This is again from the same area along strike, where we also have a volcanic sandstone, in this case a Pebdi sandstone, in between limestone of the Mosher Formation. You can see the limestone. This is a close-up of that limestone. And so at the contact between that limestone and mafic lapilli-tuff, we have the same unit, which we interpret to represent the erosion of the mafic volcanic rock. And so this suggests, because the marshy limestone is dated at, must be younger than 2780 million years, that the Whitby formation or the Whitby assemblage is Mesoarchean in age and not Neoarchean as previously suggested. We're going to test this by, this is from the Lake section, by dating. We have an example with Mike at Jack Saturday lab. It has yielded nice zircon. It's a lapidative with felsic and mafic class, and that will allow us to confirm whether the Whitby formation is Mesoarchean or Neoarchean. So in summary, the preliminary result from the work of Mohammed suggests that the Whitby assemblage is Mesoarchean and not Neoarchean as previously proposed, and was transported along an early folded truss fault along above the younger platformal sequence of the steep rock group. The second project, MSc Project, is by Gabrielle Fouillard, and it's on the geology of the Hammond Reef deposit. The Hammond Reef deposit is located along the Marmion Shear Zone. So this is in blue is a representation of the Marmion Shear Zones. So there is a widespread first initial alteration event characterized by sericite, iron-rich chlorides, and calcite, and a second alteration event, which is more localized as alteration halos around quartz carbonate chloride vein, which host the gold mineralization. Now, there is several veining events. The first veining event form laminated cruciform veins with a second veining event, which is Cindy formation and associated with hydrothermal breccia veins. And that's very representative of those hydrothermal breccia veins. In terms of mineralization, we have two generations of pyrites. We have an initial inclusion-rich pyrites that is associated with the laminated cruciform veins, and a second, more texturally uniform, massive pyrites associated with the hydrothermal breccia vein. Now, if we look at the setting of gold, gold is either within fractures or Langerian boundaries of pyrites or within the matrix. And so, and this is a traverse that was done with Jeff Marks across a laser ablation ICP-MS across some pyrite grains, and it shows that gold is present within the pyrite grains as micro-inclusion. We are going to do more work, do the element laser ablation map of those pyrite veins to confirm the setting of gold. With the help of Jeff, actually Jeff's work, we also dated some monazite and xenotimes that are associated with gold and with the alteration. And the overall ages is about 2,700 million years, which would be the age of mineralization, or at the very least the minimum age of mineralization. With the upper bracket being the age of the diversion stock, which is the Osh rock, which is dated at 2780. So it's also consistent with the previous talk by Chan in terms of the age of the formation along those northeast trending shear zones. Now this summer, Gabrielle did a structural interpretation of the Marmion shear zone. She divided the Marmion shear zone into three domains. The southern domain, which is in green, the central domain, which hosts the Hammond Reef deposit, and the Norman domain here in blue. Within the southern domains, the foliation is oriented at 0 northeast, at 060s, and the shear zones are oriented at 030. There's good also evidence of sinistral shear within the shear zone. Note that the foliation is only localized along those shear zones. This is an example with within the tonalite and strong foliation. This is one of the veins. And when we look closer at the relationship between the foliation and the veins, you can see a rotation of the foliation in anti-clockwise fashion in proximity to the vein, suggesting sinistral shear. Now, the central domain hosts the Hammond Reef deposit. Now, within the central domains, the foliation remains at the same orientation, northeast at 060. The shear zone, though, or the ice strain zone, is oriented at the same orientation, 060. So it went from 030 within the southern domain to 060 within the central domain. So it is a strong, the shear zone foliation are parallel to each other, so it's a strong zone of compression. It's also characterized by shallowly dipping veins with a down dip foliation and by those hydrothermal breccia veins that are quite abundant within an association with the Hammond Reef deposit. We have evidence of dip-slip movement. This is one of those shallowly dipping veins that are only seen within the central domain. It looks irregular, and that's because it's a weathering profile. There's shallowly dipping. This is the outcrop surface. There's a steeply dipping lineation, and we also have evidence of sinistral shear, as you can see with the S foliation rotating in the C foliation. The quartz breccia veins characterize the central domains and are syntectonic. We see some of the veins that are perpendicular and cutting across the foliation, and the veins are also, other veins are also folding, suggesting that those quartz breccia veins are synfoliation, syndeformation. Now, if we go to the northern domain, and we'll go specifically to this outcrop at the northern domain, again, so we went from the foliation remains the same orientation, it's simply localized, it's only localized within the shear zone, but the shear zones has changed orientation from 060 in the central domain now to 030. Exactly the same orientation as within the southern domain. And we have excellent shear sense indicators and textbook example of a shear extensional veining system in the northern domain. This is this outcrop. This outcrop is something like 60 to 80 meters in length. We have a shear veins, extensional veins, and simply by the orientation of the extensional veins, we can get the movement of the shear veins, which is sinistral, but there's more. So this is the shear veins, the extensional veins, the cleavage at foliation suggesting a sinistral movement. Again, in this case, you can see this is the same vein. You can see it from outcrop to outcrop. There is a dilational step over zone, again, indicated sinistral shear. And this is along the margin of that shear vein, confirming that it is a shear veins because it's laminated. And along all the laminae, we see that subhorizontal slip lineation. So what is characterizing? So what are the summary, what are the main observation? Well, there is a change in shear zone orientation from 030 to 060, where we have the Hammond Reef deposit, to 030 again. We have the Hammond Reef deposits. It's characterized by hydrothermal breccia that are synfoliation, as well as shallowly dipping veins with dip slicken line. We're in zone of compression. Mineralization is largely concentrated into this domain. It's a zone of compression. The foliation is parallel to the shear zone, which means we have more fracturing, we have more breccia, more fluids, and more gold mineralization. So the overall observation is that the Hammond Reef deposit formed within a contractional step over zone. That's the step over zone between two sinistral transcurrent faults. So in conclusion, and those are the highlights of the two projects. project by Mohammed is that the preliminary results suggest that the wedge wave assemblage is Mesoarchean and not Neoarchean, as previously proposed, and was transported along an early folded thrust fault over the steep rock platformal sequence. Conclusion from highlight from Gabrielle project on the Hammond Reef deposit is that the Hammond Reef deposit formed in a contractional step-over zone between two sinistral transcurrent faults. So Gabrielle has been able to establish the structural control on the deposit and the structural setting of the Hammond Reef deposit. Okay, thank you.